Hi everybody, we're going to start with a quick review before we get into the more complicated parts of these vectors. We're back to our robotic arm, which you can see is positioned the same way. It's the same problem and they haven't changed any of the numbers yet. But real quick, in case you have forgotten, because I know a lot of you did not watch the last video, you want to go for components. You have to put it into component form. And component form of a vector looks like this with the pointy brackets, and it is head minus tail. And then, of course, magnitude is denoted by the absolute values symbol with the name of the vector inside, and the magnitude is then the square root of a squared plus b squared. Now, a and b come from component form. So it has to be in component form first, and you have it in component form. Then you can, of course, find the magnitude. And then today we're going to finally get into direction. And I'll get into the details and how you know what this is. It's supposed to say direction. Direction is going to be the tangent of your angle. We'll use alpha usually for the direction. It's going to be b over a, which is essentially going to come again from the component form. So let's take a look at this, how all this fits together today. So here we have our robotic arm with the two parts, if you will, of the arm, and then of course its resultant. And they're asking for the magnitude of u plus v. So they're asking you for the magnitude of this resultant. So if you remember, when you add vectors, you start at 0, 0. Here's one vector. And then you go tip to tail and you start there. And there's the second vector. And then, of course, the resultant is from 0, 0 to where that second vector ends up. So you should end up with two arrowheads pointing at the answer. So let's take a look at problem number 1 here, the magnitude of u plus v. Well, it's helpful if we have it written in component form. Now, when it's in standard form like this, standard form means that the tail, the point is at 0, 0, which is exactly what we have. So our component form for the vector of u plus v, doesn't have a name of its own, is 18,3. That is not just the point, it's also component form because of the way it's drawn from 0, 0. So the magnitude of u plus v would be indicated like this, u plus v, the name inside the absolute value bars, and we would simply do the square root of 18 squared plus 3 squared. Now you'll have your calculator, and you'll need your calculator today, but of course you're not going to have a decimal answer here most likely, unless there's a decimal in the question. We'll go through the details here in a minute in terms of how to know what to do. This is the square root of 333, and that is 9 times 37, so this will be 3 radical 37. Now it says use trig to compute the direction for angle u plus, or vector u plus v. Well, I'm going to draw this just because there's a lot going on in that picture that I've drawn all over it. Just the resultant, there it is, and let's say we know that this is the point 18,3. This is exactly what we've been doing since October, which is drawing the angle in standard position. So our angle is this space underneath the resultant and above the x-axis. So our triangle always gets drawn straight down to the x-axis. This is the angle we're looking for because that's the direction. It is the direction from 0 degrees, if you're thinking about the unit circle, or from the positive x-axis. To get to that point, we went over 18, that's our x value, we went up 3, that's our y value. Well, this is opposite. 18 represents adjacent, and that's why you're going to use the tangent. And of course, we're missing the angle, so it's inverse tangent. Also, you want to make sure you're in degrees. So put your calculator in degrees, go to mode, put it in degrees. I'm going to set this up. We know that the tangent of alpha is equal to opposite, 3, over adjacent, 18. No need to reduce that, even though it does reduce. Put that in the calculator. It's going to be second tangent of 3 over 18, and you should get a first quadrant angle of 9.462. We do take this to 3 decimal places, and it should be in degrees. Now, of course, that was in the first quadrant, so that's the easiest quadrant we have to deal with. Since we're going to have to move this around depending on what quadrant it lands in, we're going to need to use all of those trig rules from all the different quadrants. So just to kind of quickly go back over those, if you're in the first quadrant, that is your alpha, or your theta, whichever you want to call it. If you're in, of course I didn't make that big enough. If you're in the second quadrant, this is going to be 180 minus your angle. In this quadrant, it's 180 plus your angle. And then, of course, in the fourth quadrant, it's 360 minus your angle. Now, you're going to have to do all of this on the calculator. Your calculator is programmed to give you a first or a fourth quadrant angle, from tangent. Right? Remember inverse tangent definition from a long time ago. So you're going to have to adjust the angle. So that's what we're going to pay attention to now. So we're going to continue to do this magnitude and direction, but for angles that are not in the first quadrant, like that first problem. So the first thing we need is component form. From component form, you can do magnitude and direction very easily. This vector is in standard form, and the scale on this is weird. So they count by twos, left and right and up and down. So every square is a 2. And so we're going to have, we have -4. So our component form is -4, and then it went up 8. So that's our component form. Pretty easy to do. We don't have to do head minus tail because the head's at 0, 0, and subtracting 0 isn't that bad. So then the magnitude. We don't have a name for our vector, so I'm just going to call this magnitude. So it's labeled. The magnitude to be the square root of a squared plus b squared. You should have no negatives. 4 squared plus 8 squared. Put that in the calculator. You get square root of 80. 16 plus 64, 80. Break down 80. 8 times 10. 10 is 2 times 5. 8 is 2 times 4. So it looks like we get 4 radical 5. Now, for the direction. This is the angle. It comes from 0, 0. That angle is not going to come out of your calculator. So we're going to deal with, obviously, this being 4 and this being 8. And we're going to use this. That's how we're going to put it in the calculator. We're going to find this angle, and then we're going to fix it by moving it or subtracting it from 180. So we know that the tangent of our angle, which I'm going to continue to call alpha, is equal to opposite 8 over -4 adjacent. Put that in the calculator, and you get 63.43. And I didn't take that to 3 decimal places, so I guess we'll take this one to 2 decimal places. Well, that's not the right answer because that's the second quadrant is where we want it. So you have to do 180 minus that number. And so the answer for the angle of this correct location is 116.56 degrees. And that's hard to read. Apologize for that. 116.56 degrees. Now, part B obviously looks very, very strange. Really hard to deal with, so let's move it. Remember, we can slide these vectors around. I would not suggest turning them, but you can certainly slide them left, right, up, down. So we can move this so that this thing is oriented or has its tail at 0, 0. If we count the squares, from its tail, it goes down 1, 2, 3, and over 3. So it goes down, even though that's I'm just counting the squares. I'm not saying, I know those are 6. So it goes down 3 squares and over 3 squares. Because maintaining the proper proportion, the correct angle is important. Don't just change the angle. So now we know that our component form is negative, because there's 6, right? Because it's counting by 2. So our component form is -6, -6. They're not asked for that, but that's easiest to do the magnitude from and the direction. So the magnitude is going to be 6 squared plus another 6 squared. Well, this is like a 45, 45, 90 because the legs are the same. So this is going to be obviously 6 radical 2. because that's the hypotenuse of a 45, 45, 90. Also, knowing that, we know that the angle is 45 degrees, but let's go through the process of setting this up. So the tangent of our angle is -6 over -6. You can put that in your calculator. That'll give you 45 degrees exactly. Now that, of course, is not what we want because we're going to measure it from 0. So we want all of this. So then we have to add 180 to that. And since this is on the unit circle, you might know this one pretty well. This is 225 degrees. So the unit circle starts to come back a little bit, but you will have your calculator for all of this. Let's take a look at part C here. I wanted to do one without a picture. A picture is super helpful, and so you may find that you want to draw one for yourself real quick just so you can figure out the quadrant it's in. That's going to be the most beneficial reason to have a quick sketch. So if we think about this from component form, so that means we go right 12 and down 4. And so here is our vector. That's fourth quadrant. So remember, fourth quadrant is 360 minus the angle. So we got to pay attention to that. So our component form is already given to us. And so for the magnitude, we would just have the square root of 12 squared plus 4 squared, which is the square root of 160. And this would be 4 radical 10. This is 16 times 10. Now, for the angle, we have the tangent of alpha. Now, if you like the picture, right, this is your angle. This is opposite over here. And this is the adjacent side. Or, remember, it's B over A. Once you have it in component form, it's so much easier. It's just B over A, and it will be every single time. You can drop the negatives. I would recommend dropping all the negatives. This would automatically give you a first quadrant answer, and it's very easy to deal with in the calculator. If you leave the negatives in there, sometimes you'll end up with a negative angle because of the definition of the inverse tangent. I would just ignore all the negatives, and you figure out for yourself what the angle is. So I'm going to get rid of the negatives on this and just do the tangent is opposite over adjacent. I know that one of those is negative, but I don't care. Then from the calculator, you get 18.44 degrees. Well, that's clearly not what we're looking for. So we're going to subtract that from 360. So we want 360 in there first, minus that. And we end up with our angle or our direction being 341. I'm better with this one here, 0.565. Now, you do not need to write down what you get from the calculator. You do need to write down what you typed in and what your final answer is. Also for the magnitude, we want reduced radical form. In part D, you'd have to figure out what the components are first. So you'd have to figure that out by doing, remember, it is head minus tail. So just a quick reminder, component form here would be 7 minus 1, and then -10 minus 1. So our component form would be 6, -11. And then from there, of course, you could apply what we just did. Now, the second thing we're going to do today is called resolving a vector into components. And you can tell, you can see that the formula is right here. So x has always gone with cosine and y has always gone with sine, and that's what this is. Now remember, this symbol is magnitude. So now we're going to go backwards. They're going to give you the magnitude and the direction, and we're going to put it back into the components. That's what they mean by resolving it into the components. So far we've started with the components and we've calculated magnitude and direction, and now you're going to be given magnitude and direction, and you're going to be asked for the component form. We do have some rules with this. If you're on the unit circle, no decimals. If you are not on the unit circle, then you can have a decimal. So you're still going to have to recognize the unit circle values. So I'm going to put part A right here, right by, because you can sort of see it there. I'm going to put it up here by where the formula is so that I can show you how to use the formula as well. So we're going to calculate x and y. So we know that x is the absolute, or the magnitude rather, times the cosine of the angle. And then the y value is the magnitude of that vector times the sine of the angle. It's as simple as that. You do one formula for x, one formula for y, and put them back together written in component form. So we know that the direction is 225. We can see that, and we know where that is. We know what that's the unit circle. So 225 is over here. So all scholars take calculus. Sine and cosine are both negative, but we know that because it's in the third quadrant. Remember, your answer is going to be components, so we're left and down. So we know that we're negative and negative. So we know that x is going to equal 8, which is the magnitude, times the cosine of 225. So we have 8. The cosine of 225 is negative radical 2 over 2. And we'll reduce that. We get negative 4 radical 2. Now, of course, this is an easy one because we know the sine is, or the y value is going to be exactly the same thing. 8 times the sine of 225. This is a little bit unusual that these match. So we have 8 and then negative radical 2 over 2 again. So we know that this is the same value. So the component form for part A is negative 4 radical 2, negative 4 radical 2. Remember, you have to write it A, comma, B. All right, so let's take a look at part B. This one clearly not the unit circle. We don't know a a negative 95 degree angle. So let's just set this up. For part B, x would equal 50 times the cosine of negative 95, and y is equal to 50 times the sine of negative 95. All you have to do is type that into your calculator. This is not inverse. This is just regular sine. Whatever the numbers are, you write them down. Remember, we're going to 3 decimal places. So for x, we get negative 4.358. And then, of course, for the y value, which is now our b value, we get negative 49.810. Put it in component form, please. Let's do one more that is on the unit circle. Those are usually a little bit harder because you do have to remember the unit circle. Remember, use your calculator. Some things, 0.707 is radical 2 over 2. The 0.866 number, that's radical 3 over 2. If you know those little fractions and those decimals, it makes using your calculator so much easier. So for the x value, we're going to have 15 times the cosine of 30. Here they put the magnitude right on the vector. So we have 15 times radical 3 over 2. So we get just 15 radical 3 over 2, I guess. And then for y, we have 15 times the sine of 30, and the sine of 30 is 1/2. So we get 15 over 2. So the vector form is going to be 15 radical 3 over 2, and then 15 over 2. Now, the last little bit of this isn't anything new. It looks a little bit crazy. You can see there's a lot of writing here. We're just going to put them together. Take a look at, we're going to skip all the way down here, as you can see, on try these B. And I'm going to change this first problem to vector S plus vector T. I'm going to need some more space here. This is going to be a lot of writing, but not really much work because we'll put it in the calculator. But I want to write it out first. So I'm changing that to a plus. It's a minus, but I just changed it to a plus. So first thing we have to do, remember the order. This is where it gets a little bit strange. The order is component form first. We don't have component form. So in order to add these two vectors together, we need their components. And then, of course, they want to determine the magnitude and the direction of the sum or the resultant. So it is not just adding them together, but it is then doing all the things that we just did. So the first thing is, in order to get to that A over B and all that magnitude stuff, we need A and B, which is resolving it into its components. So for vector S, I'm going to probably write all over here just because we're running out of space here. According to the directions, vector S is got a magnitude of 10, so I'm going to write it out like this. 10, and then we want to do cosine of 125. And then for the y or the b value, it's 10 sine of 125. Vector t, put this in components. We don't have the numbers yet. 15, and then it says the direction is negative 15, so cosine of negative 15, and then 15 sine of negative 15. So in order to add these together, I just stacked them up like this kind of on purpose. It would be all of these things added. So this is going to be 10 cosine of 125 plus 15 cosine of negative 15. And then for the y value, 10 sine of 125, I guess it's really b in my component form, plus 15 sine of negative 15 degrees. So you want to put that into the calculator and get an answer for A. I'm going to skip all this. We're not doing any of this. Get an answer for A and an answer for B. So this is the component form of vector S plus vector T. We haven't answered the question yet. We're just getting to component form. We're going to go to 2 decimal places, 8.75 and 4.31. That came just right out of the calculator. No tricks, just typed it in. Make sure you're in degrees. Now, for magnitude. So for magnitude, the symbol is the absolute value bars, and the name of the vector is vector S plus vector T. Remember, it is the square root of A squared plus B squared. Put this into the calculator. You don't need any parentheses. You don't have anything negative. You don't have to change any signs. Just put it into the calculator. This is going to be 9.756. Now, for the direction, we've got to think about what quadrant this is in. So if we think about drawing this component form, it's right and up. So we're in the first quadrant. So we're going to get the answer right from the calculator. So for the direction is that the tangent of our angle is equal to B over A. If you remember that, it's so much easier to just look right at the components. Again, this would go into the calculator, and whatever you get out of the calculator is exactly what we want. We don't have to move it at all. It's 26.211 degrees. So check that and make sure you're getting that from your calculator. The assignment, and I'm going slow on purpose here, is right here on page 453. In case you need to pause this. It is problems 10 through 17, all on page 453. Pay attention to your units. I will tell you that number 17 is super, super tricky. This is in minutes, and it's not in minutes, right? So it's problem is written in hours, so you're going to have to put that back into minutes, because you can see it's 20 kilometers per hour.